Chemical kinetics is a subset of chemical physics that's really interested in how fast reactions occur. Or we can say the time component of how materials change over time. It's useful from a purely practical point of view when we want to know how long it would take to make a given product. If we're in engineering, it might help us to decide whether we should increase or decrease the temperature or pressure, or how the reaction time is going to change if we add a catalyst. From a scientific point of view, it tells us about the mechanism of the reaction. How fast the reaction occurs can tell us about how the reaction occurs. All those ideas are right in line with other physical topics, where we work to understand the precise relationships between different phenomena. To do this, we interpret those relationships as mathematical models. Now, whether you enjoy doing math or not, at its heart, math really isn't about numbers, any more than, say, a spy novel is about the alphabet. When we work with ideas mathematically, we're examining their relationships. Now let's look at a rate, for example. If we're talking about a rate of speed, like kilometers per hour, we can see that it's a distance per unit of time. For chemical kinetics, we talk about the rates of reaction as the change in the amount of a reaction or product per unit time. In solutions, it's more convenient to talk about the change of concentration, and that looks like the rate equals the change in the concentration per time. For the simplest model reaction, A converts into B. The stoichiometry tells us that for every 1A that reacts, 1B gets made, which means that the concentration of A goes down at the exact same rate as the concentration of B goes up. Or if we imagine one that has a different stoichiometry, like 1A plus 3B turns into 2C, we would see that for every 1A that gets used, we need 3 Bs and we make 2 Cs. Or we could write it to say that the negative change in A per time is 1/3 as fast as the negative change in B per time, or 1/2 of the concentration of C per time, and in the opposite direction. Or if we want to make that completely general, we can use the stoichiometry of the different reactants and products to equate between the reaction rates of each of the reactants and products.